Okay, you guys, we're starting a new chapter now called Chapter 9. I know we were in Chapter 11 before. We're going back to Chapter 9. That's how it goes. We're starting off with the basics. These are quadratic functions. We're starting off with the basics of quadratic functions. Today's stuff's going to be pretty simple, but there's a lot of words coming at you and stuff. I'm also using a lot of the examples out of the book. It would be a good idea if you have your book to open it up and follow along in this section as I'm going over in section 9.1. I'm doing a lot of the problems out of the intro section to section 9.1. So I'd look at that if I were you. Anyways, here's what they look like. Section 9.1, quadratic functions, equations and functions. Okay, here's the first thing. Now this doesn't really necessarily only apply to quadratic functions. This applies to any equation at all, a line or anything like that, a circle, any kind of equation of any kind of line, circle, any kind of shape or whatever. It is, the question says, are the points 2, 1 and -1, -7 included on the graph of y equals -3x squared minus 4? For a point to be included on the graph, that means when you plug that point in for the coordinates x and y, you get a true statement. That's what a graph of anything is. It's just a picture of all the points that make that equation a true statement. So what you do, for instance, if I want to check the point 2, 1, like they have for the first question, the point 2, 1, I want to know if it's on that graph. I go to the graph, which is y equals -3x squared minus 4, and the point 2, 1 refers to x coordinate 2, y coordinate 1. So I plug 1 in for y equals -3 times 2 squared minus 4. I plug 2 in for x and 1 in for y. Okay, now I want to go ahead and do this. Now, one thing that people make a mistake on sometimes here is, what is -3 times 2 squared? Do I go -3 times 2 is -6 and square it and get 36? Or do I go 2 squared is 4 times it by -3 and get -12? There's a difference between -12 and 36. How do we know? Well, the saying that everybody is familiar with, people expect Miami Dolphins at the Super Bowl. There you go. Oh yeah. That tells you what order. Parentheses, exponents, multiplication, division, addition, subtraction. So this is exponents, right? Exponents happens before multiplication. So you do not do -3 times 2 is -6 and square it. You instead say 2 squared is 4 times -3 is -12, so you get 1 equals -12 minus 4, 1 equals -16. That is not true. 1 is not equal to -16. So is 2, 1 a point on the graph? The answer is no, it is not a point on the graph, because when you plug those values in for x and y, you do not get a true statement. So let's try the next one. The point -1, -7. I'm going to do the same exact thing with that. So here we go. I'm going to plug it into y equals -3x squared minus 4. Okay, that's going to be -7 equals -3x squared minus 4. -7 is -3 times -1 squared is 1. So this is 1 times -3 minus 4. -7 is -3 minus 4. -7 equals -7. Yes, that is true. So is that a point on the graph? Yes. It really is that easy. That's how you tell if a point is on the graph. Now, those were so easy that I'm not even going to give you homework problems asking you that. I just wanted you to understand that that's how you tell if a point is on any a line or a parabola or whatever it is you've got. You just plug those in for the variables and see if you get a true statement. That's how you tell if a point is on a graph. Okay, So we'll go to the next thing. Actually, the next thing is going to be up there on the screen. And it says that in a parabola is the graph of a second degree equation. We're going to talk a lot about parabolas. Okay. In a parabola, in the parabola y equals ax squared plus bx plus c. That's just a general equation for a parabola. Any parabola can be written in that form. Okay. If a, the letter a, the one we're talking about is that a right there. That's the a. If that a is greater than 0 is just another name for positive, right? If that a is positive, greater than 0, the parabola opens up. So this is what a parabola looks like. It's going to open up something like that, okay? If a is less than 0 or negative, it's going to open, the parabola is going to open down like that. That's what we've got. So very, very, very simple. You just look at that number in front of the squared term. If it's positive, it opens up. If it's a negative, it opens down. It doesn't matter what the size of the number is. It just matters, is it positive or negative? That tells you if it opens up or down. It's that easy. Okay? Now, let's do a couple examples. Okay? I'm going to work some magic right here. But let's read them first. Does the graph of the parabola y equals negative 3x squared plus 7x minus 14 open upward or downward? Nothing matters except for the number in front of the x squared term, okay? Look down here. Does the graph of the parabola y equals 3/4 x squared plus 3x plus 11 open upward or downward? Notice, these two guys don't affect whether it opens up or down. These two guys don't affect whether it opens up or down. Keep your eyes on the thing. Keep your eyes on the thing. Something magic is going to happen. Watch, watch. Ready, watch. Holy moly. What did I do? I just made these guys stand out. Why? Because this is what determines whether it opens up or down. Okay, look. -3, that's a negative number, right? So it opens downward, okay? Look at this guy, 3/4. That's a positive number, so guess what? Opens upward, this guy. It really is that easy. Oh my gosh, can you believe it? Okay. How about this guy? Well, you may just look at it immediately and go, hey, this stuff is so easy. Okay. Look, there's a plus in front of the 5, in front of the x squared, plus 5. So it must open upward. And I say, whoa, 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 slow down, slow down. That is not the case here. Watch. Why? Now, why am I saying that? Because if you look, see how the y and the x squared are on the same side of the equal sign? Remember, the equation we were looking at is y equals ax squared plus bx plus c. That's the general form for the parabola, okay? With the y over on this side and the x squared over on the other side. So this is not in a form that you can actually look and decide whether the parabola opens upward or downward. You want to get y by itself, all the other stuff on the other side. So here's what we're going to do. We're going to, we already have y over here and it's positive, so we're going to leave it like it is. And we're going to minus 5x squared to cancel that. We're going to add 3, cancel that, and it becomes y equals negative 5x squared plus 7x plus 3. Now it is in that form. Now we could look at what's in front of the squared term, which is negative 5, and say that's a negative number, so this parabola opens down. Great. Okay, now moving on. That thing basically just shows what I just showed you here. In fact, I'll do one more. This is straight out of the book. So if you're looking in your book, you'll see this problem in the intro section to this section. Okay, it says 2x squared plus y equals 5. Does that open up or down? Well, again, Look, the x squared and the y are on the same side. You can't have that to determine if it opens up or down. So you got to move this over. You always want the y to be positive. This guy may be positive or negative. Y equals negative 2x squared plus 5. Doesn't matter that it doesn't have an x term. Notice the number in front of the x squared is negative, so this thing opens down. It really is that easy, and that's what it says in your book, and that's what it says on that screen up there, basically what I just told you. Okay? Now, this is another thing straight out of your book. That's why a lot of the stuff for today's lesson is going to be straight out of the book. That's why it's a good idea to have the book open to that so you can see what it's saying. Okay. We're going to talk about minimum and maximum values. Minimum, just think about it in everyday life. What do these words mean? Minimum means lowest. Minimum, lowest. Maximum means highest. Minimum, lowest, maximum, highest. Every parabola is going to have either a minimum or a maximum. If it opens upward, it always has a lowest point. That point's called the vertex, right? The minimum point always lies at the vertex. Or if it opens downward, there's always a highest point. Guess what? That's also called the vertex. The vertex of a parabola is the lowest or highest point on the parabola, and that it's also going to give you the minimum or maximum value. If a parabola opens up, it always has a minimum value. It's always the y coordinate of the vertex. If it opens down, it always has a maximum value, which is also the y coordinate of the vertex. The words up there say if a is greater than 0, that means positive. The parabola opens up, and the y value of the vertex is the minimum value of the function. Just exactly what I told you. If a is less than 0, in other words, a is negative, the parabola opens down, and the y value of the vertex is a maximum value. Makes sense. So they're showing a couple of things up here. Let me see. This one right here. See how this vertex right here is at negative 3, 0. It happens to lie on the x-axis. So guess what? The vertex is negative 3, 0. It has a minimum value of 0. The y value. The minimum or maximum value is not the x coordinate of the vertex. It is the y coordinate. So the vertex of that one is negative 3, 0. So it has a minimum value of 0. Okay. This next one right here, this guy, look at the vertex. It's 1, 2, 3 over, and 1, 2, 3, 4, 5 up. 3, 5. The vertex is point 3, 5. So, and it opens downward, meaning that vertex is a, get your fingers off there.
Sorry, I was trying
to
readjust
I know.
it.
But if the vertex is 3, 5, it opens down, so it's a maximum, and the maximum value is 5. It's always the y coordinate of the vertex. Just hold it until the end. I'm almost done with all this. Okay. Okay, this is also some more wording from your book. Again, we're just going into a lot of definitions and a lot of explaining what words mean, but it's really not that difficult. Okay, to tell whether the graph of each quadratic function opens upward or downward, and explain, okay? Well, 3a, look, there's a negative in front of the x squared. F of x, by the way, is just a fancy name for y. You will see y written as f of x, or f of x, it's interchangeable with y. So that's just like saying y equals negative 4x squared minus x plus 1. So it's negative, so it opens down. 3b, wait a minute, look, the y and the x squared are together on the same side, so you would have to add 5x squared over to move this guy over, right? You'd have to add the 5x squared to move it over there, making it positive, so this would be a parabola that opens upward, okay? The minimum value of function is the least possible y value of the function, like this, look, the lowest y value. A maximum value of a function is the greatest possible value for the function, and it's also the y coordinate of the vertex. Okay, the highest or lowest point on the parabola is a vertex. Therefore, the minimum or maximum value of quadratic function occurs at the vertex. And I've already told you that. Okay. Okay. So look at that one, the first one. The vertex is 1, 5, and it opens down, so it has a maximum of 5 at the vertex of 1, 5. Look at this one. The vertex on this one is -2 over in the x direction, down 1, 2, 3, 4, 5. -2, -5 is the vertex, and it opens upwards, so it's a minimum value of -5. Notice, it's not a minimum value because this number's negative. It's a minimum value because it's opening upward. That makes this, it doesn't matter that this number is positive or negative. That's not what determines a maximum or minimum value. Notice this is a positive number 5, and it happened to be a maximum value, but that's not why. It's not a maximum because it's a positive number. It's a maximum because the parabola opens downward. Okay? So there we go. All right. So, we did that pretty much. We're good there. Okay, this one says, okay, we're going to talk about the domain and the range right now. The domain. The domain is a set of x values covered by a function. The range is a set of y values. So it's just the total set of x values is the domain. The total set of y values is the range. Okay? When you have, like, say, a line, let me just draw a line and show you there. So I'm just drawing a standard line that looks something like that. Suppose that's a straight line, right? Notice these arrows right here means it just keeps going forever this way and forever this way. Now, if you think about it, this is the x direction right here. This is the y direction. So let's just look at the x values. They're the horizontal x values. Notice, if this is, actually, I guess I should draw some axes in here. I guess it doesn't really matter that much. Okay. So here's my x and y axis, right? My line, it keeps going on forever and ever. And think about it. It just keeps going on and on and on and on and on. No matter how far out you go in the x direction, there's going to be a y value that goes with it because the line just keeps going for infinity that way and infinity that way. So every x value, you say, what if I go out to a million, billion, trillion? Yeah, there's going to be a point that a y value that goes with that. So all the x values are covered by this. Same thing with the y values. Look at this line. Every y value is eventually going to get covered because this thing just goes on for infinity this way and infinity this way. There's no restrictions on any y value. All x values are covered. All y values are covered. So the domain of this line is all real numbers. No restrictions on the x. If the range is also going to be all real numbers. Not that exciting. You're like, oh, but that all real numbers, all real numbers. Let's look at parabolas. Okay. That one, the top picture they have up there, right there. This parabola is vertex at 2, 1 right here. 2, 1 right here. And it opens upward. Okay. So what is the domain and the range of that? Well, think about it. See these arrows that make it go up and it goes for infinity that way? So it keeps going up that way. So think about it. No matter what, it just keeps going and going and going. So every x value is eventually going to be covered because you could go as far as you want in the negative direction or as far as you want in the positive direction. Those arrows mean that it just keeps going. This keeps going up and it keeps getting a little wider and a little wider and a little wider. Eventually, every single x gets covered, so there is no restrictions. The domain, all right, like this, the domain is just all real numbers. Okay, the domain of a parabola that opens up or down is all real numbers. And so take a look at the one that opens down, right? See these arrows right here? That means it goes infinity down this way, but it's always getting a little bit wider and a little bit wider. So it's also going to have all real numbers. Okay, so the domain of that one is going to be all real numbers. In fact, the domain of any parabola is all real numbers. In fact, I like to put it this way. The domainer is a no-brainer, right? The domainer of every single parabola is all real numbers. Now the range is something different. The range is the set of y values. Now look at this parabola up here. It's vertexed at 2, 1, right? So the lowest point, the lowest y value is the y coordinate of the vertex, 1. Notice, no y value under 1 is covered on this parabola. Look, y value 0. Does this ever hit a y value 0? No. Does it ever hit a y value -1? No. The lowest y value it ever hits is 1. Now it covers, it keeps going for infinity, right? So starting at 1, it covers everything else above that. So you would say this. So how would you say that? Well, the domain is all real numbers greater than 1. So the range is going to be y is greater than or equal to 1, right? But none of the numbers under 1 are covered in the y direction, so they're not part of the range. Only the ones that are covered, or the y values that are on the graph, are the ones in the range. So how about this guy? Well, its vertex is -1, 1, 2, 3, 4. -1, 4. So notice 4 is the highest y value that is on that graph, right? No other. Look, 5 is not on the graph. 6 is not on the graph. 4 is the highest y value that's on the graph. So the range here is going to be y is, and notice it's either 4 or smaller. So it has to be y is less than or equal to 4. So that's what we're going to do, less than or equal to 4. So there's the range. So if it's a parabola that opens up, it's always going to be y is greater than or equal to y coordinate of the vertex. If a parabola that opens down, the range is always going to be y is less than or equal to y coordinate of the vertex. Okay, pretty straightforward. All right. So let's look at these two guys, the domain and the range. 5a right there. The vertex is -2, -4, right? -2, -4, and it opens up. So here's the deal. The domain is going to be, remember the domainer is a no-brainer. The domain, all real numbers, right? The range, since it opens up, it's going to, -4 is the lowest y value. So the range is going to be y is greater than or equal to -4, right? Because that's the lowest one. All the other y's are that much or bigger. Okay, how about 5b? That was 5a. Okay, 5b. Well, the vertex is 2, 3, 2, 3, and it opens down. So, vertex is 2, 3, opens down. Okay, now 2, 3 opens down. They want to know what is the domain and the range. Well, again, the domainer is a no-brainer. All real numbers, right? What is the range? The range is going to be, let's see, 3. It's going to be y is either greater than or equal to, or less than or equal to 3. I just need to know, is this greater than or equal to or less than or equal to? Well, does this thing open up or down? It opens down, making this the highest y value, meaning all the other y values are going to be less than or equal to that thing. And there is the homework. Homework number 46. Page 548, 16 through 27 all, and 41 to 46 all. So there you go. That's the homework for this assignment. Again, it shouldn't be too difficult. It shouldn't take you too long. It's a fairly quick deal. So enjoy, have fun. I'll see you next time.